Welcome to the Rode & Schwarz tutorial LTE Technology and LTE Test, a desk side chat. My name is Christina Gessner and I am Technology Manager for LTE at Rode & Schwarz.
And my name is Andreas Rösler. I'm Technology Manager as well, but dedicated to North America with focus on LTE.
This tutorial will provide you with a detailed insight into the cellular standard of LTE, long-term evolution of UMTS, and its test requirements. Together, Andreas and me will take you through the following contents. First, I would like to provide some background information and motivation why LTE was introduced. Then we will present the technology basics for LTE, like key parameters, the OFDMA multiple access scheme and downlink frame structure, the single carrier FDMA and uplink frame structure, LTE network and protocol architecture, LTE UE categories. Then we will have a closer look at major radio procedures for LTE, that is the cell search, the system information broadcast, the random access, the bearer setup for the evolved packet system bearer, downlink and uplink data transmission, mobility, and the MIMO multi-antenna technology. Finally, we will look into test requirements for LTE, including base station or eNode B RF testing, terminal or UE RF testing, then the LTE wireless device testing from R&D up to the conformance, and LTE field trial testing and coverage measurements. So let's start with the motivation for LTE. Why LTE is being introduced into the UMTS. First of all, LTE is based on the success of high-speed packet access, HSPA, worldwide. As you can see in the chart, the subscriber numbers for HSPA have been steadily increasing over the years. HSPA growth is based on the uptake of mobile data services worldwide, and today more than 250 networks worldwide have already commercially launched HSPA. Mobile data traffic is growing exponentially, caused by mobile internet offerings and improved user experience with new device types. This means that there's a growing need for capacity enhancements in existing networks, and also the subscribers expect improvements like data rate enhancements and latency improvements. So LTE is today accepted worldwide as the long-term evolution perspective for today's 2G and 3G networks, and this includes networks based on wideband CDMA HSPA, GSM Edge, TDS CDMA, and CDMA 2000 technologies. So let's have a look at the LTE background. When was LTE started? So work on LTE was initiated already end of 2004, in December 2004, with a 3GPP Release 7 study item on evolved UTRA and UTRAN. A quote from the motivation of the study item says, "With enhancements such as HSDPA and enhanced uplink, the 3GPP radio access technology will be highly competitive for several years. However, to ensure competitiveness in an even longer time frame, that is for the next 10 years and beyond, a long-term evolution of the 3GPP radio access technology needs to be considered." Technically, basic drivers for LTE have been reduced latency, that is better interaction times between the network and the user in terms of reduced round-trip times, higher user data rate, peak and average, improved system capacity and coverage, as well as cost reduction for the network operator means migration to the new technology and also operating the network. So let's have a closer look at the major requirements that were identified for LTE during the study item phase in 3GPP. First of all, the data rates. Peak data rates of over 100 megabit per second in downlink direction and over 50 megabit per second in uplink direction should be achieved with LTE. And as we see later, these targets have even been exceeded. Improved spectrum efficiency. The spectrum efficiency for LTE should be 2 to 4 times better in comparison to the 3GPP Release 6 technology. That means HSPA. Improved latency. Radio access network latency, that is the round trip between the UE side, the radio network controller on the UTRAN network, and the UE shall be below 10 milliseconds. And also the control plane latency shall be reduced significantly. LTE supports scalable bandwidths. Values from 1.4, 3, 5, 10, 15 and 20 MHz shall be supported. Both paired and unpaired spectrum shall be supported. That means a frequency division duplex and a time division duplex mode, FDD and TDD mode, are supported in LTE. LTE shall also support interworking with legacy network in terms of 2G, 3G networks of today, GSM Edge, wideband CDMA, HSPA and so on. Cost efficiency. This means that for the network operator, LTE shall provide reduced capital and operational expenditures, including also the backhaul situation, which should be improved for LTE. Cost-effective migration from legacy networks shall be possible as well. So this is really an overview. A detailed summary of requirements for LTE has been captured in a technical report of the study item phase 25.913, which you can find on the FreeGPP website. This slide shows now the overview of the UMTS evolution and the different evolution stages per FreeGPP release. So this is true for FDD and TDD modes. So UMTS from the beginning supports FDD and TDD operation, and we see here the evolution paths for both FDD and TDD. So it starts with the wideband CDMA and TDS CDMA of FreeGPP release 99 and 4, and then in FreeGPP release 5, HSDPA was introduced in FreeGPP. Release 6 then brings the HSUPA as well. And with HSDPA, data rates up to 14 megabit per second peak downlink can be achieved, and with HSUPA 5.7 megabit per second peak uplink data rate can be achieved. So this is really a significant enhancement in the data rate already in FreeGPP release 5 and 6. So as we have seen, HSPA is a big success, but also HSPA evolution does not stop yet. So there is HSPA Plus features in release 7. HSPA Plus further enhances data rate in the downlink. Up to 28 megabit per second peak downlink data rate are possible by using, for example, MIMO multi-antenna technology and also higher order modulation schemes. In the uplink, by using 16 QAM modulation, 11 megabit per second peak uplink data rate are possible. So up to here, HSPA, HSPA Plus, they are all based on wideband CDMA 5 MHz operation. Now in the FreeGPP release 8, LTE was specified. So LTE, as we have seen, data rates of over 100 megabit per second are possible in downlink. So we have 150 megabit per second peak value for 20 MHz operation and by using a 2x2 MIMO. In uplink, LTE achieves 75 megabit per second uplink data rate, peak uplink data rate. But LTE is not the only part of FreeGPP release 8. There's also HSPA Plus improvements that are part of release 8. This is very important because also very interesting features for HSPA Plus are coming up here. So you see that data rate for HSPA Plus could further be improved up to 42 megabit per second by combining 64 QAM higher order modulation schemes and MIMO. Not only the data rate improvement is shown here, also the improvement in the latency. The latency is typically measured in the round trip time. So you see here improvement from one evolution stage to the next. LTE will probably commercially be introduced 2010. So there's indications that network operators will start operation commercially then. So also LTE is further being developed already. There's a study item initiated in FreeGPP on LTE Advanced, and this will make LTE a true 4G system. So the ITU has set the requirements for 4G systems to achieve 1 gigabit per second data rate in low mobility scenarios. And this will be possible with LTE Advanced. So right now there's investigations ongoing in terms of the study item how LTE can achieve this. And right now this is a study, so it will probably be part of release 10 core specifications of LTE.
Christina, one question. If LTE Advanced is covered in the release 10 and LTE itself in the specified in release 8, so what about the release 9 of 3GPP?
Sure, the work on release 9 is already started. There's some enhancements to LTE coming up, like work on the home eNote B for LTE, for example, and so on. So there's already work items defined for release 9, and this will bring further improvements for LTE and also for HSPA+.